Here I have taken some keys. Let us create a red black tree by inserting each key one by one. So let us start. The first key that I have is 10. I have to insert 10. So remember, the insertion will be done just like binary search tree. Just like binary search tree. So first key is 10. So always a newly inserted node will be red node, right? So this is inserting 10. Insert 10. I have inserted 10. But this is the first node and it is a root node. So you remember, root node must be black node. So I should change this color and make it as black node. So I'll change it to black. So this is 10. 10 is inserted. Now next key, 20. So here I will continue, insert 20. So this is already 10. So where 20 should come? 20 is greater than 10, so it should come on the right hand side. So 20 is this one. Now, when you are inserting a new node, it should be a red node and its parent is black, then no problem. No problem. No problem with the balancing the height. You don't have to do anything. It's perfect. Now, next key is 30. 30. So where 30 should come? Here I will say insert 30. Inserting 30. Right now this is 10 and its child is 20. This is 20, which is red now, and 30, where it should come? 30 is greater than 10 and greater than 20. So 30 should come as a right child of 20 and it's a new node. So remember, always a new node should be a red node. Yes, I have inserted. Now, if you see, there is a red-red conflict. So whenever there is a red-red conflict, then you have to do some adjustment for making it as a balanced red-black tree. So there are two approach for adjustment. Remember this one. First one is recoloring. Second one is rotation. Now I will take some sample example here and I'll show you what does it mean by recoloring and what does it mean by rotation. Then we will continue with this one. So now we will learn those two steps, recoloring and rotation. Here I have examples. See this. This is a newly inserted node and its parent is red. This P is for parent, N is for newly inserted node. And this is grandparent. So I'll write G here. This is grandparent. And this is uncle for this node. So it means the sibling of a parent. So sibling of parent means uncle, right? So we use the term uncle here. So for a newly inserted node, its parent is red and its uncle is also red. Then what to do? Recolor. Recolor the node. So how to recolor? Change these to black. So make these as black. And this will remain red only. New node will remain red only and this will become black. And the parent, we should make it as red. Parent should be red. This is what you have to choose. Change the colors. So this is called as recoloring. And after that, if suppose P is a root node, then you have to make it black. So that will also become black. If it is not root node, then it will recursively, it will check upwards, that is towards the parents of P. So this is the procedure of recoloring. Just I have shown you recoloring, that you remember. Okay, how to do while creating this one, I will explain you. So don't have to worry about that. If you simply try to understand, this is confusing. Let us use it, it becomes easy and simple. Now next thing. If suppose newly inserted node is this one, red, and its parent is also red, then only you have to do something, right? If it is black, then no need to do anything. If it is red, then check uncle. I said nulls are also black. I'm not showing other nulls. The diagram looks congested. So I'm showing only this uncle. This is null. This is also black. So parent is red, but uncle is black, then you have to perform rotation. If a parent is red and uncle is also red, recolor. Parent is red, uncle is black, perform rotation. Then if you remember from AVL tree, the rotations we saw were LL, RR, LR, RL, 4 types of rotations we saw there. Yes, a similar one. We will change the names here. So this is RR. So we'll perform rotation along this one. So instead of RR, or left or right, we have a single name that we can say zigzag rotation. This is RR rotation. So this B becomes parent, and A becomes left child, and C becomes right child, and this root remains black, and these children will become red. So you have to give the colors like this. And otherwise, if this is the new node, this is parent, that is red, and its left child, that is uncle, and it is black. So parent is red, uncle is black. Then we have to perform, this is RL rotation. So this is called as zigzag rotation. So zigzag rotation means RL as well as LR, and zigzag notation means LL as well as RR. So we have this name. So this is combining both the rotations. So only two things we have to take from here. What is that? Newly inserted node, if its parent is red, then check uncle. Uncle may be red, uncle may be black. If uncle is red, recolor. If uncle is black, then perform rotation. That's what. This is the point that we have to pick up from here, right? We don't have to go into details, just ignore them. When we are creating it, we can understand everything. So let us continue. So here we have red conflict. Then what is uncle here? Uncle is this node, and this is black, which is null. So it means parent is red and uncle is black. This is the new node, right? So we have to perform rotation. So let us perform rotation over this grandparent. So rotations are performed over grandparent. So this is just our rotation. We know we have done this in AVL tree. So let us perform rotation, and I will write on the tree here. So this 20 will come here, that will become black, and its left child, that is 10, and the right child will be 30. So this is 10 and this is 30. This is after rotation. Watch it closely, right? If you are unable to follow at any place, just pause and watch it again. And you do it on pen and paper. Just take a pen and paper and practice it also by yourself. Okay. Now let us continue. We have finished till here. Now let us insert 50. So here I will write on the top, insert 50. Where 50 should be? Start from root, search for 50. 50 is greater than 20 and greater than 30. So it should come on the right side. It's not there. So insert it. So newly inserted node 50, that will be of red color. This is the new node. Now this is the new node. This is parent, and this is grandparent, and this is uncle. Now there is a red conflict. As I said, if there is red conflict, then only you have to perform a recoloring or rotation. So red conflict is there. Parent is red and uncle is also red. So if parent is red and uncle is also red, means change the color. So let us change the color. So in this tree only I will modify, change the color, make this as black, and this also as black, and this as red. So parent and uncle as black and grandparent as red. But this grandparent is a root of a tree, and root must be black. So again we have to modify this one. So especially you should check this, that root is black or not. If it is root, then keep it black. So this is after inserting 50. This is the tree. So once we saw rotation, second we saw recoloring. That's it. We have to continue like this only. Let us insert next key, that is 40. Insert 40. I'll draw this one. Here I have taken a same tree. Now insert 40. 40 is greater than 20. 40 is greater than 30. 40 is less than 50. So it should come on this side. So here I should insert 40. This is red node. Every new node is red node. This is new node, and this is parent, and this is grandparent, and this is uncle. Uncle is black. Now if you observe, parent is red and uncle is black. So if parent is red and uncle is black, that is uncle is black, we have to perform rotation. So which rotation we should perform on this one? This is right and left based on the grandparent. So using grandparent we have to perform rotation. So it is double rotation, right? If you remember double rotation, that is a zigzag rotation we have to perform. After rotation, I will write on the tree directly here. 20 is here and 10 is here. Upon this rotation is performed. So if you perform rotation like this, then 40 will come here directly from AVL tree. If you remember, directly you do that one, right? So don't take two steps, directly do it. 40 will come at this place. So 40 is this one. right child is 50 and the left child is 30. So this becomes 30 and this becomes 50 and grandparent remains red and these will become red. So this is after performing rotation on this one. So this is the final tree we got after rotation. Now before continuing insertion of remaining keys, let me show you the height of black. How many blacks in this path? 1, 2 and null is also there, 3. 1, 2 and null is also there. So I will draw that null also. Okay, these are black. So 1, 2, 3, 1, 2, 3 and in this direction if you go 1, 2 and this is one more black 3, 1, 2 and one more black 3, 1, 2, this is black 3, 1, 2, this is black 3. So in every direction you go, it is 3 only, it is same only. So you don't have to take a special care of maintaining number of blacks. You don't have to do. Follow this one. Follow this one. Right? If there is color conflict, either recolor or perform rotation. That's what. So you will get a red black. So I will insert remaining keys. For that I will remove this one. Next key is 60. So insert 60. So this is the final tree that I have. So in this only I will insert 60. 60 is greater than 20, greater than 40 and greater than 50. So 60 should come here. So as a right child of 50, this is 60. Now this is a newly inserted node, this is parent and this is uncle and this is grandparent. Now check this, newly inserted node red and this is also red, red conflict, and check uncle, uncle is also red. If parent and uncle both are red, then what to do? Recolor. How to recolor? Modify these parents as parent as well as uncle as black. So these are black. Then grandparent as red. Now see this, interesting. From this point you see this. This is very important. Now again for grandparent, check in its ancestors. Check this one. This is parent, that is black. This is red. So red and black, it is not a conflict. If no conflict, then stop. If suppose this was also red, then you have to check upwards. So we have a tree up to here only. So this is red and this is black. So if you have red under this black, then no problem. If there is red, then we have to continue. So the thing that we learn, one more thing we learn here is that after recoloring, grandparent becomes red, then again you have to check it in its ancestors. So parent is black, so no problem. Stop it. Now I will take this same tree here, I will draw it up to 60 we have finished, then I have to insert 70. So first of all I will draw the same thing there, then I will insert 70. So this is the same tree I have taken, black, black, red, black, black, red, black, black, red, black, black, red. So same thing. Now insert 70, inserting 70. 70 is greater and greater and greater and greater. So 70 comes here as a right child. So 70 will be here. See, I am trying to insert always on the right hand side, so we can come across all the possibilities here. If you do on the left side also, it's the same thing. So we are learning every possibility here. Okay. So now if you observe, there is red conflict, red conflict. This is a new node, this is parent and this is grandparent, and uncle is null, right? I am not showing null, all these are nulls, right? These are also there, null, but we are focusing on this one, so that's why I am drawing only that one. This is uncle. Uncle is black. So this parent is red and uncle is black. Perform rotation around grandparent. So perform rotation around this one. So after rotation, how it looks like? This is 20, which remains same. This is 10, remains same. And this is 40. Okay. And this is 30, which remains same. We have to perform rotation over 50. So at 50 comes what? 60. And left child is 50, right child is 70, this one. So grandparent was black, so it remains black only, and these children, when we perform rotation, so this 60 will become black and these children will become red. Now let us confirm whether it is balanced or not. So for that, let us count the number of blacks along the path. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. All the paths I have checked, there are all 3 black nodes, right, in this example tree. So it is balanced. Number of blacks along the path are same. So this is balance. Now till 70 I have finished. Now I have to insert 80. So I have to remove everything from the board. So if you want to take a snapshot or copy this one, you can copy it. I will take this tree once again here and I will continue rest of the keys. So I have taken that tree here. Now we will insert 80. This is interesting. We are going to learn one new thing again here. Let us see this. Insert 80. Where it should come. 80 is greater than 20, greater than 40, greater than 60, greater than 70. So 80 should come here as a right child of 70. This is right child. Now red conflict. This is a new node. This is parent and this is uncle and this is grandparent. Red conflict is there. So check uncle color. Uncle is red. Parent is also red. Uncle is also red. Then what to do? Recolor them. Make parent and uncle as black and grandparent as red. So check this one. I will change this 50 to black color and 70 also to black color, and this is 60, that is grandparent, as red. Now remove this and consider this as a new node now, and this is parent, this is grandparent, and this is uncle. What I was saying, that when grandparent becomes red, then you have to check in its parents and ancestors also. So that's what this was, recoloring. The result of recoloring, this became red. Again there is a red conflict, red conflict. And when there is a red conflict, check uncle. Uncle is black. So for this node, parent is red, uncle is black. So perform rotation around grandparent, So around this grandparent we perform rotation. So we know very well from AVL trees, we have seen this. We will perform rotation in these three nodes and we'll do that rotation. So 40 will move up, 40 moves up, right? And 20 and 10 comes this side. So this is for 20 and 10 is black color as it is, right? Grandparent will become black and children will become red, right? So at 40 who will come? 60. This is 60. And its child is 70 and 80. I will copy them as it is. This is 70 and this is 80. I have taken these as it is. Now 30 is black. Where it should go? It was left child of 40. It will come on this side. So it will be right child of 20. This is 30. And what about 60 is left child? 50 is as it is. This is 50. It is black. So you can see that out of these three nodes, this has went as became a grandparent and this became red color. This is red only and this became black. So this is black, this is red, and this is red only. This is the final tree. So you can see that the insertion was done here, but the rotation is performed here because there was red conflict at this point. Now confirm whether it is perfect or not. So how to know that? Count the number of blacks. So here are black, right? Nulls are also black. So count the number of blacks nodes. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, and 3. 1, 2, 3. So along this path, 1, 2, 3. Yes, 1, 2, 3. It's balanced. So in all directions, see, I am getting 3 only every time. So don't think that always it should be 3. Don't assume this one. It depends on the height. I have few keys only. So height is small. That's why I am getting count as 3, right? So as it is going bigger, number of black nodes will increase definitely. So this is the new thing we learn, that is, first is recoloring, second is rotation. So we have done both the things here. So newly inserted node is always leaf node, and then we have to balance the red black tree. So till here we have finished. Now I have to insert 4 and 8. So let us do it quickly. I will insert 4. So 4 is smaller than this one and smaller than this one, smaller than 10. So 4 should come on the left of this one. Always we insert it as a red color. So 4 is red color. Check. Red conflict? No, it is black. So no need of any rotation or any adjustment. It's perfect. The next key is 8. 8 is less than 40, less than 20, less than 10, but greater than 4. So it will be added as a right child of 4. So this is 8. Now check red conflict. Yes, there is red conflict. This is new node, this is parent, this is grandparent, and this is uncle. I will remove these. This will be confusing sometimes. This is uncle. Only one null we are looking at. So uncle is black, parent is red. Perform rotation. So which rotation I should perform? See, this is zigzag rotation because this grandparent's parent, this child is left child and this is right child. So we know this is double rotation. So I should do it like this. So what will be the root? New root, this 8 will go there and 10 will come as a right child. 10 will come as a right child and 4 remains there only. This is the result. And grandparent is black and its children are red. That's all. This is balance. So we perform zigzag rotation. Rotations we know already, right? Which rotation you should perform, you can clearly see that. Okay. Then whichever direction you have a red conflict, see that it is LR, RL, LL or RR. So from AVL you can borrow that. Otherwise it's difficult if you try to work in zigzag or zigzag. So it will be a new thing for you. So you can adjust yourself with the rotations of AVL tree. So I have performed like LR rotation I have performed. Now let us confirm whether it is perfect or not. Check the height. Okay, leave nulls, just count black. 1, 2. Okay, null is there. Definitely null is always there. So ignore it. 1, 2. 1, 2. 1, 2. 1, 2. So in every part we have 2 black nodes, including null, 3 black nodes. So this is the final red black tree for the keys that I have taken. So this is the procedure for creating red black tree by maintaining all the properties we have learned. Root is black, the number of blacks along any path are equal, there are no consecutive red. And lastly, one more important thing, in this tree, whatever the height is, just you ignore reds, reds, the height will be less. So actual height is log n, but including reds, it's a double. So it's allowing us to increase up to 2 log n. So that's how the height is 2 log n. If you remove reds and see it is log n, suppose, then including red, it is 2 log n because colors are red or black. Okay, if only all blacks, it is log n. Only all reds, it is log n. Red and black both are there, so 2 log n. So that's all about red black tree. I have shown you how to create a tree and what are the operations you have to perform. Recoloring and rotations we have done and we have learned how to generate. So you have to practice this whole thing by yourself. Do it once by yourself. Without that, you cannot remember it and you cannot do it again. So you have to do it. All those steps you do it once. Then later on you can add more keys by yourself also. That's all in this video. In the next video I will show you how it is related to 2, 3, 4 trees. And once you see that, it's become damn easy. Red black tree becomes a damn easy if you're comfortable with 2, 3, 4 trees. I'll take the same keys and I will show you how it is related to 2, 3, 4 trees.